Hi, this is Jelyn from the Honors Tutorial. Our topic for today is about evaluating limits at infinity. Direction: evaluate the following limits. So this is how you are going to read number 1. Limit of 5x minus 4 over 3x plus 7 as x approaches to positive infinity. How are we going to solve for this? We have here the steps. Number 1, determine the literal coefficient with the greatest exponent in a given expression. So what is a literal coefficient? Literal coefficient is actually the letter beside the number here. So the letter that we can see in our expression is only x. So therefore we have to compare the exponents that you can see in your variable or literal coefficient. We have to choose the greatest. So in here, as you can see, we have here x and x. What is the exponent? Okay, the exponent is 1 here. But we cannot see any exponent, right? Before, we cannot see it. It is because when the exponent is 1, we are not writing it. Again, when the exponent is 1 in our literal coefficient, we are not writing it. So it is like an invisible number. So 1 is an invisible number as an exponent. Now we have here x raised to 1 and x raised to 1. We cannot compare it because they are equal. So therefore, simply write x raised to 1. Next, step 2. Divide each term with x. Why with x? Because x is the literal coefficient that we chose earlier. So that is x. Later, I will show you how are we going to do step 2. And also, x raised to 1 can be written as x. As I have mentioned earlier, 1 as an exponent is invisible number. So therefore, you can just write x raised to 1 as x. So that's why in our step 2, it is stated that we have to divide each term with x. We are referring to x raised to 1. Next, step 3. For step 3, we have to simplify. The question is how? We have to apply theorem on limits at infinity. What is the theorem? It states that let r be any positive integer, then limit of 1 over x raised to r is equal to 0 as x approaches to positive infinity. Later, I will show you how are we going to use these steps to solve number 1. Let's solve it together. Again, our first step is to identify the, the literal coefficient with the greatest exponent, and that is x. So just write the given first. So that is 5x minus 4 over 3x plus 7. And then after that, we have to divide each term in our expression by x. So it will become 5x over x minus 4 over x over 3x over x plus 7 over x. And then, of course, we have to simplify that. Five x divided by x is 5. Why? Why is it 5? It is because when dividing, look at this variable or literal coefficient here. We have to subtract the exponents of the variable or the letter here. So 1 minus 1 is 0. So therefore, for you to remember this, if the variable are the same and also if their exponents are the same, kindly cancel the terms or the variables. And that's it. We have 5. And then copy this operation. Minus 4 over x. We cannot divide 4 and x because your numerator, which is 4, is a constant. And your denominator, which is x, is a variable. So therefore, we cannot divide it. What are we going to do? We have to copy 4 over x. Next, we also have to solve for the denominator. 3x divided by x. Same process as 5x over x. As you can see here, we have here x at the numerator and x at your denominator. You have to cancel it. Again, in dividing variables or literal coefficients, you have to subtract the exponents. But for you to remember it easily, if the variables or the literal coefficients are the same and their exponents are the same, simply cancel it out. So therefore, we have here 3. And then you have to copy the operation. So you have here plus. As you can see, for 7 over x, we cannot simplify it anymore. Why? Because the numerator is a constant or a number. And your denominator is a variable or a letter. So therefore, we cannot divide it. So we have here 7 over x. And then, this is the time where you are going to apply the theorem that we have encountered earlier. That theorem simply states that if you have here a constant, and if you have here in your denominator a variable raised to any exponent, automatic, the value of this will become 0. So it will become 5 minus 0 over 3 plus 0. So simplify it. 5 minus 0 is 5, 3 plus 0 is 3. So the answer here is 5 over 3. And that's it for number 1. Next, let's have number 2. For number 2, no worries about it. We have here same steps, 1 to 3. As earlier, step 1, determine the literal coefficient with the greatest exponent in a given expression. Step 2, divide each term with x. We will change the exponent of x because literally it should be 1 here. But based on step 1, we have to determine the literal coefficient with the greatest exponent. So the literal coefficient here is x and x, but we have to choose the greatest exponent. So that's 4. Because 2 is less than 4 and 4 is greater than 2, so we have to choose 4. So we have to divide each term with x raised to 4. Step 3. Simplify. We have to apply theorem on limits at infinity again. the same theorem that we have applied before. Let r be any positive integer, then limit of 1 over x raised to r is equal to 0 as x approaches to positive infinity. Let's solve number 2 using these steps. Solution. Write the given first, don't forget that. Then over x raised to 4 plus 12 over x raised to 2 or x squared. So according to that, we have to divide each term by x raised to 4. So this is what will happen. Now we can divide this by the highest exponent that we have here. So we have here x raised to 4 over x raised to 4. But later, I will show you the other way to solve number 2. Okay? So now, how are we going to solve for this? Let's have 10 over x raised to 4 over x raised to 4 first. So let's have 10 over x raised to 4 divided by x raised to 4. So as you can see, we can change raised to 4 into a fraction. We will just write 1 here below in our denominator, then x raised to 4 is a fraction now. Let's apply the right way on dividing the terms or the expressions. The first thing that you have to do when dividing expressions is to change this operation into multiplication and then reciprocate the second given. So when we say reciprocate, you have to interchange the position of the numerator and the denominator. So 1 is our denominator, then it will become our numerator. And for x raised to 4, since it is our numerator, now it will become our denominator. So therefore, we can now multiply it. 10 times 1 is 10. X raised to 4 times x raised to 4 is x raised to 8. Now we have here our value of 10 over x raised to 4 over x raised to 4. Same process for 12 over x squared over x raised to 4. Let's solve for it. 12 over x squared divided by x raised to 4. Same process, please change x raised to 4 into fraction. So just write over 1. Next, copy the first given and then change the operation into multiplication and then reciprocate x raised to 4 over 1. Then it will become 1 over x raised to 4. Then multiply numerator to numerator. So we have here 12 over denominator to denominator, that's x raised to 6. Let's continue. So now, let's have 10 over x raised to 8 and 12 over x raised to 6. So we have here 10 over x raised to 8 plus 12 over x raised to 6. We cannot simplify it anymore because 10 is a constant while x raised to 8 is a variable. Also for 12, that is a constant and x raised to 6 is a variable. So therefore, applying the theorem that we had, this first term will become 0 plus 0. So the final answer is 0. And that's it for number 2. But of course, we have here our second way of doing number 2. It is more easier than this. Let me just introduce it to you. For number 2, you can just separate these two expressions that we have. So it will become this. Limit of 10 over x raised to 4 as x approaches to positive infinity, plus the limit of 12 over x squared as x approaches to positive infinity. Now, applying the theorem that we have, if we have here a constant and also a variable here in your denominator with any exponent, this will become 0. Then again, applying the theorem that you have, if your numerator is a constant and if your denominator is a variable, no matter what the exponent is, then it is equal to 0. 0 plus 0 is 0, and that's it. It is simpler and it is easier. You may choose solutions which you are more comfortable in doing. Doesn't matter if it is solution 1 or solution 2, as long as your answer is correct at the end. Next, number 3. For number 3, we have here the steps. Steps are the same. Determine the literal coefficient with the greatest exponent in the given expression. And step 2, divide each term with x, not just with x, because our literal coefficient here with the highest exponent or the greatest exponent is x squared. So the exponent of x here should be 2. Next, we have to simplify. Let us just apply the theorem that we have, this one. Oh, by the way, this is a negative infinity, so therefore, this part, positive infinity, will change. But the theorem is still the same. It will become limit of 1 over x raised to r is equal to 0 as x approaches to negative infinity. As you can see, this part changes, but the theorem is still the same. So let's do that for number 3. Solution. We have to divide each term by x squared. So let's have 9x squared over x squared minus 3x over x squared plus 8 over x squared. Next, we have to do the same thing in your denominator. 12x squared over x squared plus 2x over x squared minus 4 over x squared. So after that, you have to simplify. For you to simplify it a little faster, um, look for the variables and then observe your exponent. If they are the same, please cancel it. And then we have here 9. Why? Why did we cancel it? It is because in dividing the numerator and denominator, for the variable, you have to subtract the exponents. 2 minus 2 is 0, so therefore we can simply cancel it. And then copy this, the operation, so minus So we have here 3x over x squared. Just copy 3. And then after that, please observe the exponents. For x, we have 1. You have to subtract the exponents. 1 minus 2 is negative 1. But let's have the absolute value of it. So that's 1. The question is, where are you going to put x raised to 1? Because x raised to 1 divided by x raised to 2 is equal to x raised to 1. You have to write x raised to 1 in your denominator. Why? Because it has the greatest exponent or the greater exponent here in our expression. Next, copy this operation. So plus, we cannot simplify it anymore because 8 is a constant already while the denominator is a variable. So we have here 8 over x squared over, simplify your denominator. Same thing with 9x squared over x squared. As you can see here, the variables are the same, the exponents are the same, automatic cancel. So we have here 12 plus 2x over x squared. Copy 2, subtract the exponents. So we have here x raised to 1 as our answer. Write it below. And then after that, copy this, the operation. So minus 4 over x squared. Why? It is because you cannot simplify the numerator and denominator anymore because the numerator is a constant while the denominator is a variable. Next, apply the theorem that we have learned earlier. Just copy 9 minus 0 plus 0 over 12 plus 0 minus 0. 9 minus 0 plus 0, that is equal to 9. 12 plus 0 minus 0 is equal to 12. We have to simplify this. Just think of a number that when you divide by 9 and 12 will not produce any remainder. We can use 3. Let's try. 9 divided by 3 is 3. 12 divided by 3 is 4. So the final answer here is 3 over 4. So that's it for this topic, limits at infinity. So we have here the positive infinity and also the negative infinity. I hope that you have learned something today. God bless and goodbye.